Now, let's look at distances on the small circle. So, for example, find the distances from P, 74 degrees west, 42 degrees north, and then Q, 12 degrees east, 42 degrees north. We are taking pi to 22/7. So let's come back to the diagram here. So these are the lines of latitude. Lines of latitude. These are the south and these are also in the north. So when a question is given, let's look at this alpha. So the small r is equal to big R cos alpha. Now the alpha is only given from the first question that we did. That one we were not concentrating on the lines of latitude. It was only on longitude. So that is why we didn't pay attention to the alpha. But here it is lines of latitude. So we need to pay attention to the alpha. And for example, if these points, these 2 points are on this X and I'm told to find the distance between them. Since this is the small circle, I'll be interested in the radius. This is the per this circle. We need this center and this is the radius of them. But this R here is the radius of the big circle. That is either longitude or the latitude, 0 degrees. Okay. So the alpha here is normally given in pair. So for this one and then this one is the alpha. These two, since they are the same, they determine the alpha. So our R cos alpha will be the 6,400 cos 42 degrees. So now let's look at this question. Find the distance from points from P, 74 degrees west, and then 12 degrees east. So 74 degrees west. Let me assume this is 74 degrees west, and then 12 degrees east. So this is 12 degrees east, and then 74 degrees west. Okay, so 74 degrees west. This is 74 degrees west, and then 42 degrees north. So 42 degrees north, I'm assuming this is 42 degrees north. So this point, since this is the 74 degrees west, and then also 42 degrees north, and then 12 degrees east. So 12 degrees east is this one. So this is the 12 degrees east. So the point P is here, and then Q is also here. And I'm to find the distance between these 2 points. So that is going to be my length of arc, which is always 2 pi r theta over 360 degrees. But since we are dealing with the small circles, we'll be interested in the 2 pi small r theta over 360 degrees. But our small r is equal to big R cos alpha. Okay, so let's start from the theta. Our angle theta is equal to, we have 2 different locations, that is west and east. So in that sense, we need to add the angle. So 74 plus 12, and that is going to be 86 degrees. So that is my theta. Then my r, small r, becomes big R cos alpha. So r is equal to 6,400 cos alpha is 42 degrees. I've told you already. So that is this angle here. And alpha and beta are complementary. So 42 degrees. So 42 degrees. So R becomes 6,400 on a calculator. 6,400. So that is our hypotenuse. Okay. So 6,400 plus 42 is equal to 4,756.126. So that is our radius, small r. So in that sense, L is equal to 2 pi, which has been given as 22/7. So 2 times 22/7 times the small r, which is this one. So that is 4756.126 times the theta we have 86 all over 360 degrees. And on the calculator, that is going to give us 7141. So 7141.31 kilometers. So that's the distance from point P to Q. This is on the small circle. So that is that. Now let's look at another example. 2 towns P 42 degrees west, 30 degrees north, and Q 18 degrees east, 30 degrees north are on the surface of the earth. Find the time it will take a pilot flying at 600 km per hour to travel from P to Q along parallel latitude. So this along parallel latitude is just to waste your time, just or to tell you that it is along the latitude. Okay, and we have to take pi to be 3.14. Okay, so as we know, our R is equal to, as we know, 6,400 kilometers. Then our small r is equal to 6,000. Before then, let me ask, what is our alpha? Maybe you can pause and then come up with your answer later. I hope you'll guess it right. Now, our alpha is in the question. You see 30 degrees north, 30 degrees north. So that is going to be our alpha, 30 degrees. So our R becomes, which is R cos, R is equal to R cos alpha. So R is 6,400 times, 6,400 cos alpha, which is 30 degrees. So now our length becomes 2 pi small r theta over 360 degrees. So our small r is what we have here. So that is going to be 2 times 3.14, that is our pi, times our r, which is 6,400 cos 30, then times the theta. So our theta, let me write it here. Theta is, since we have 2 different locations, so we need to add them. So that is 50, 60. So our theta is 60 degrees. So times 60 all over 360 degrees. So this on the calculator gives 5801.05 kilometers. So this is the distance between the 2 towns, between the 2 towns P and Q. Now we are also told to find the time. And a pilot flying at 600 km per hour. So before then, our speed is equal to distance over time. Okay. So we are given the speed, so we need time. So we need to make t the subject. So t becomes this and this, that is distance d over speed. So t is going to be our distance. We had this, which is 5801.05 divided by the speed, which is 600 kilometers. So here, let me add kilometers and then kilometers, then per hour. So per hour. So this and this will go away. So dividing this and calculator is going to give us t equals 9.67 hours. So the time it will take the pilot will be 9 hours then we may try to look at 0.67 minutes. So that is our second later, we'll talk about it. So that is that.